here's the next problem I'm going to work, and even though this is a slightly more complicated problem, I'm going to work it pretty quickly, largely because many of the methods are exactly the same as what I just showed you. But also, I want to do two more problems, and if I work this one fully, then there isn't going to be time for both. So I think you should do the same thing as last time. Pause it, read it, draw your diagram of the situation, and then I'll go on. So here's my very artistic drawing of the situation, and notice we've got two different accelerations, right? So this is two different segments of motion. Each one of them is uniformly accelerated, but the entire motion from start to finish isn't, because there's a change in the acceleration at some point. So we can use a UAM equation to get from the initial place to this intermediate place 120 meters away, and another UAM equation to do our final jump. And so we're sort of setting up two linked UAM problems here to get to our final answer. So I'm going to just quickly write out the variable names that we'll want, and I'm going to organize it as two different problems side by side. Okay, so there are all the variables we might know or want to know. And note that instead of i's and f's, I've used zeros, ones, and twos. So for our first part, the zeros are all our initials, and the ones are all our finals. And for the second part, the ones are our initials, and the twos are our finals. So I'm going to now pause it again, and you should fill in what you think all these values are, and I will do the same. So there I've filled them all in, and note I corrected a mistake I had made. I had the wrong acceleration written down there. And notice that this is the same as this, and although we don't know what it is, this is going to be the same as this. So now we need to see a way through. So we would like to solve for x2, because that is the final position, and that's going to tell us how far this has gone. So what we really want is delta x 1, 2. But we don't know that. To solve for this, we would need to know three things. Well, look, we know 2. If we can get one more, then we'll be in good shape. Well, look, this one we can find out of the first part. And so if you come back to the first part, look, we know delta x, we know vx0, we know a, and so we know three things, and we can find the fourth. So here's our strategy. We're going to find vx1, and then we'll know enough to find x2. So I'm only going to sketch the rest, and you can do it yourself, and I will give you the answer. So the sketch of the rest is we need to choose an equation here. So again, we need an equation that includes these four variables, and it's actually the same one. So you're going to want the one that I've called equation 3, and that's going to get you vx1, and you can bring that over here. And now you want an equation that includes delta x, vxi, a, and delta t. And that would be the one I've called equation 2. So there is the sketch of your solution. I suggest you pause it, work through that, and when you unpause it, I'll show you the worked out with an answer. So here it is all worked out. Note, I wrote down my first equation. That's equation 3, except I specialized it to the symbols I'm using. I solved. This time we want the positive solution. There's the answer I get. I plugged it over here. Wrote down this one in the form with xf and xi, since xf is actually what I'm looking for, and xi isn't 0 here. And that gives me this final answer. And we know it went 120 meters in the first part. And in the second part, it was going 31 meters per second the whole time. Now, we don't know how long this first part was, how long in time it was, but it makes sense that it might have gone farther in the second part. It was going faster here. How long, really, to know that, we'd need to know delta t1. And so a good step to do in assessing whether you believe this would be to now find delta t1.